Imagine a silent invasion happening right now inside your body. Trillions of foreign organisms are trying to turn your cells into their personal playground. To stop them, we use a weapon called chemotherapy. But there is a $1 trillion question. How do we design a drug that is deadly enough to kill a bacteria but smart enough to leave your own human cells completely untouched? Today, we are looking at the selective toxicity of the antibiotics and the 4 ways they destroy the enemy. We look for the biochemical and physiological differences between the invader, the prokaryote, and you, the eukaryote. Here are the 4 ways we take them down. In pharmacology, chemotherapy isn't just for the cancer, it's the treatment of any infection using the drugs that have selective toxicity. This means the drug takes advantage of the biochemical differences between the invader, the prokaryote, and the host, the eukaryote, which is you. Before we look at the weapons, we need to know the strategy. Drugs usually fall into 2 camps, bacteriostatic and bactericidal. The bacteriostatic, these drugs do not kill the bacteria, they simply freeze them, arrest their growth so the immune system can finish the job. Bactericidal, these are the assassinators, like they kill or the irreversibly damage the bacteria. Now let us look into the 4 weapons where the antibiotics attack. Weapon 1, the wall breaker. Bacteria live under high internal pressure. They need a strong wall to stay intact, and drugs like penicillins block the final transpeptidation step, making the cell wall weak. Without this support, the bacteria cannot handle the osmotic drive. Fluid rushes in, cell swells, and it bursts through a process called lysis, and you don't have a cell wall, so those drugs ignore your cell entirely. And now coming to the leaky seal. If the wall is an armor, the cell membrane is the skin. Drugs like polymyxins act like cation detergents. They literally tear into the membrane by displacing the vital calcium and the magnesium ions, and this creates holes that cause leakage of the intracellular contents. And the bacteria basically bleeds out its life force and dies instantly. And the weapon 3 is the factory, like blocking the protein synthesis. Bacteria needs proteins to survive, and they use ribosome factories to make them. But their factory 70S is built differently than ours 80S. Tetracyclines and aminoglycosides jam the small 30S machine, while the macrolides chloramophenicol shut down the large 50S machine. By stopping the translocation, we stop the bacteria from building anything it needs to live. Weapon 4, the blueprint erasers, the nucleic acid separation. Finally, we attack the core blueprints. Fluoroquinolones block an enzyme called the DNA gyrase, which normally entangles the DNA so it can be copied. Without it, the DNA becomes a tangled and useless knot. Sulfonamides acts as an imposters, blocking the bacteria from making folic acid, which is essential for building DNA. Since you eat your folic acid instead of making it, the drug kills the bacteria and leaves you alone. These drugs may look like precision weapons, but bacteria don't stand still. They mutate, they adapt, and they resist. In the next video, we will break down each antibiotic class, link them directly to their mechanism of action, and expose the molecular tricks bacteria use to survive, from the beta-lactamases to efflux pumps and the target modifications. Because understanding how antibiotics work is only half the story, and understanding how they fail is what makes you dangerous. In the pharmacology, the real enemy isn't the bacteria, it's the resistance. Every antibiotic tells a story. The resistance is how the bacteria rewrite it. Thank you for watching the video. If you like the content, please share, subscribe, and comment below if you want any topic to be understood.